For the circuit shown in the figure below, find the current through and voltage across each circuit elements at t equals to 0 plus. Also find dVc upon dt 0 plus and dIL upon dt 0 plus, and the circuit is at t equals to 0 it is going to close. This is a resistor of 2 ohm. This is inductor of 3 Henry. Similarly, this is resistor of 4 ohm, and this is capacitor of 5 farad. Now we are going to do solution of this question. First step first. In step first, we are going to recognize whether the circuit is in energized condition or de-energized condition. For this, we have to look at t equals to 0 minus circuit. At t equals to 0 minus, the switch is in open position. At t equals to 0 plus, the switch will be in closed position. So we are going to check energized and de-energized condition at t equals to 0 minus circuit. So at t equals to 0 minus, the switch will be in open position. At t equals to 0 minus, if the switch is in open position, there will be no current driven by this voltage source, and there will be no current in the inductor, and there will be no current in the capacitor. If there is no current in the capacitor won't charge, and there won't be any voltage across capacitor. So at t equals to 0 minus, the switch is open, there will be no current in the inductor, and there will be no voltage across the capacitor. So by observation, at t equals to 0 minus, there is no current in the inductor and no voltage across capacitor. Therefore, we can say that the circuit is in de-energized condition. Now step 2. In step 2 we will draw circuit of t equals to 0 minus, and here in step 2 we will calculate current through inductor, that is IL0 minus, and voltage across capacitor, that is VC0 minus. We will draw circuit at t equals to 0 minus. At t equals to 0 minus, the switch will be open. The switch will be open. First of all, we will draw the position of switch. This is t equals to 0 minus circuit. This is voltage source, plus minus 15 volt, and the switch is in open position at t equals to 0 minus. This is resistor of 2 ohm. This is de-energized inductor. So de-energized inductor at t equals to 0 minus will be or this de-energized inductor at t equals to 0 minus, it is no need to change. It is no need to change. That is of 3 Henry, and this is a resistance of 4 ohm. This remains same, and this is de-energized capacitor. So de-energized capacitor at t equals to 0 minus, if we see from table, it is no need to change. This is capacitor of 5 farad. So now we will assume the direction of current. Let us suppose in this branch current is I0 minus, and in this branch let us suppose this is current IL0 minus. In this branch let us suppose the direction of current is IR0 minus, and in this branch let us suppose current is IC0 minus. So our target is to calculate the current in the inductor, that is IL0 minus, and the next target is to calculate voltage across capacitor, that is VC0 minus. So first of all we will calculate this branch current. Since we know that this switch is open, so we can say this I0 minus is equals to 0 ampere. Since the switch is open, so no current is driven from this voltage source, so we can say that this IL0 minus is also 0. So in inductor inductor current is IL0 minus. In this branch IL0 minus, in this branch we can say that IR0 minus is equals to 0 ampere. Similarly this IC0 minus is also 0 ampere. Now our target is to calculate inductor current, that is IL0 minus. So IL0 minus is 0 ampere. So from continuity relation we can say that IL0 minus equals to IL0 plus equals to 0 ampere. So from continuity relation we can calculate IL0 plus equals to 0 ampere. So our main target was to calculate IL0 minus. So IL0 minus is 0 ampere. So from continuity relation IL0 plus equals to 0 ampere. Now next target is to calculate this BC0 minus. Since this current IC0 minus capacitor current is 0, so capacitor won't charge. If capacitor won't charge, there won't be any voltage across capacitor. So BC0 minus is equals to 0 volt. Again from continuity relation we can say that BC0 minus equals to BC0 plus equals to 0 volt. So our target was to calculate IL0 minus, and IL0 minus is 0 ampere, and next target was to calculate voltage across capacitor, that is BC0 minus, and BC0 minus is 0 volt. So in step 2 we have to draw circuit at t equals to 0 minus, and we have to calculate first of all this branch current, and at finally we will calculate IL0 minus and BC0 minus. Step 3. In step 3 we will draw circuit at t equals to 0 plus, circuit at t equals to 0 plus, and at t equals to 0 plus circuit we will calculate, first of all we will calculate branch current, and then we will calculate IL0 plus current through inductor. Similarly we will calculate voltage across capacitor, that is BC0 plus, and then we will calculate whatever the question has asked. So let us start. So circuit at t equals to 0 minus. So circuit at t equals to 0 minus, at t equals to 0 minus, at t equals to 0 plus, the switch will be in closed position. First of all we will draw switch, and then voltage source of 15 volt. Similarly there is a resistor of 2 ohm. At t equals to 0 plus, since we know that this is inductor, de-energized inductor. So de-energized inductor at t equals to 0 plus, it is replaced by open circuit. Since at t equals to 0 plus, de-energized inductor is replaced by open circuit, but there is physically there is an inductor, but at t equals to 0 plus, inductor act as an open circuit, but we know that there is physically inductor of 3 Henry. Physically there is inductor of 3 Henry. Similarly, next capacitor remains as it is of 4 ohm, and resistor remains same, 4 ohm. Similarly this is de-energized capacitor. So de-energized capacitor at t equals to 0 plus, is replaced by short circuit according to table. De-energized capacitor is replaced by short circuit at t equals to 0 plus, but physically there is capacitor of 5 farad. Now let us assume, according to previous circuit, we have in this branch the current is, let us suppose, I0 plus. Let us suppose in this branch I assume the direction of current as IL0 plus. Similarly, in this branch I assume IR0 plus, and in this branch I assume IC0 plus. And our target is to calculate IL0 plus and voltage across capacitor. Voltage across capacitor, that is BC0 plus. So first of all, let us calculate this branch current. So according to, if we see the circuit, we can say that this is open circuit. So in open circuit there won't be any current. So we can say IL0 plus equals to IL0 plus equals to 0 ampere. Similarly, if we analyze this circuit, we can say that the current, this 15 volt source will drive a current of I0 plus in 2 ohm. Similarly, this IL0 plus is 0 because this is open circuit, so no current will flow in this part. This I0 plus will totally flow through this part, and since there is short circuit path, so all this current will flow through this short circuit path, and this I0 plus will follow this path, this whole path. So we can say that this 15 volt voltage source will drive a current of I0 plus in this branch, and this is open, no current will flow in this part. All this current will flow through this short circuit path, and no current will flow through this 4 ohm. So we can say that IR0 plus, since no current will flow through 4 ohm, no current will flow through 4 ohm, so we can say that IR0 plus is 0 ampere. Now in this whole path there is a flow of current of I0 plus. So in this closed path we can see that there is one voltage source and one resistance of 2 ohm. So in this path we can calculate I0 plus by using Ohm's law. That is, I0 plus, according to Ohm's law, I0 plus equals to this 15 volt voltage divided by resistance. Resistance is 2 ohm. So in this closed path we have voltage of 15 volt and resistance of 2 ohm. So we can calculate I0 plus equals to 7.5 ampere. Since this I0 plus totally flow through this capacitor path, so we can say that IC0 plus is also equals to I0 plus. So IC0 plus equals to 7.5 ampere. So we can see that we have calculated all of the branch current, I0 plus, IL0 plus, IR0 plus and IC0 plus. We have calculated all the branch current. Now we will calculate this inductor current. Now target is to calculate inductor current. That is IL0 plus equals to, since this is open, so IL0 plus equals to 0 ampere, and at t equals to 0 minus, we have calculated from continuity relation. We can see that IL0 plus equals to 0 ampere, or we can calculate from t equals to 0 plus also. Similarly, next target is to calculate BC0 plus. So by seeing this circuit, we can say that this is short circuit and physically there is capacitor. So this is short circuit, so voltage across short circuit is equals to 0, that is BC0 plus is 0 volt. We can say by seeing this circuit, that is voltage across capacitor is 0 volt, or we can say that from continuity relation we can say that BC0 plus equals to 0 volt. Now finally we will calculate whatever the question has asked. So in this question we have to find the current through and voltage across each circuit element. Across each circuit element we have to calculate current and voltage of each element. So let us find. So current through this 2 ohm, I2 ohm 0 plus equals to, in this 2 ohm resistor there is flow of I0 plus. So I0 plus is 7.5 ampere. 7.5 ampere. Similarly, voltage across 2 ohm, that is B2 ohm 0 plus equals to current into resistance. In this 2 ohm resistor there is current of I0 plus and resistance is 2. So B2 ohm 0 plus is I0 plus current into resistance, that is 2. So I0 plus is 7.5 into this 2 ohm equals to, this is 15 volt. Similarly, current through this inductor, that is IL 0 plus equals to 0 ampere. Now we will calculate voltage across this inductor, that is BL 0 plus. Now to find voltage across inductor, physically there is inductor, but at t equals to 0 plus, this inductor we have as open circuit. So we will find voltage across this inductor or voltage between these two terminal, that is BL0 plus. So to find voltage between two terminal, we will use starting and finishing point concept. We will use the concept of starting point and finishing point. Let us suppose this is starting point and this is finishing point. So to use the concept of starting and finishing point, we need polarity of these two terminal. So to find the polarity of these two terminal, we will find polarity by the direction, with the help of direction of current. With the help of direction of current, we will find the polarity of these two terminal. That is, current enter in this physically there is physically there is inductor, so current enter into this terminal will be positive and this terminal will be negative because current exit from this. Similarly, current enter from this part, so this will be positive, this will be negative. Similarly, current enter into this part, this resistance, this is plus, and exit from this part, so this is minus. Physically there is capacitor, but at t equals to 0 plus, capacitor act as short circuit, but physically there is capacitor. So current enter into this capacitor, this will be plus, and current exit from this capacitor, so this is minus. So to use the concept of starting point and finishing point, we need polarity in this terminal, and this polarity in this terminal can be obtained from the direction of this current. So we have got polarity. Now we will use concept of starting point and finishing point. So this is starting point. Let us suppose this is starting point. Always assume the potential of this starting point as higher potential and the potential of this finishing point as lower potential. So this is starting point, higher potential, and sign convention for higher potential is plus, so use plus. And the voltage of this terminal is, this is V, terminal of this terminal is VL0 plus, VL0 plus. Now we will follow the path, we will follow this path, we can follow this path also, we can follow this path also. So now I am going to follow this path. So from this path here to here, I want to go from this minus terminal to plus terminal. So this is will be plus, minus to plus, finally we get plus, so here is plus. Similarly, we have to calculate the drop of this, that is drop is current, that is 7.5 into resistance is 2. Similarly, we will move from here to here, plus to minus, so plus to minus, finally we get minus, so we will write minus, and the voltage of this voltage source is 15. Now we will move to the finishing point. The finishing point has is in lower potential, so as it is in lower potential, we will assume lower potential as negative. We will use sign convention of lower potential as minus, and the terminal of this finishing point is assumed to be, since the voltage potential of this finishing point is low, so we assume the potential of this finishing point as 0, since it is low potential. So equals to 0, we will get VL0 plus equals to 15 minus 15 equals to 0 volt. Now this is first, this is second, and in third we will calculate I4 ohm 0 plus. I4 ohm 0 plus equals to in this 4 ohm there is no current, that is IR0 plus. In this 4 ohm that is there is a flow of current of IR0 plus, and IR0 plus is 0 ampere. So I4 ohm is 0 ampere. Since there is no current in this 4 ohm, so we can say that V4 ohm, voltage across 4 ohm 0 plus equals to current into current is 0 into resistance is 4, that is 0 volt. Now we will calculate this capacitor current and voltage across capacitor. So in this physically there is capacitor, so current through this capacitor, that is IC0 plus, IC0 plus, that is 7.5 ampere, and voltage across capacitor, that is VC0 plus equals to 0 volt. So we have calculated the current through each circuit element and voltage across each circuit element. Now finally we also the question has asked dVc upon dt0 plus and dIL upon dt0 plus. So we know we have ready-made formula of this. We know IC0 plus equals to C dVc upon dt0 plus. This is the ready-made formula of capacitor current, that is IC equals to C dVc upon dt. So at t equals to 0 plus, IC0 plus equals to C times dVc upon dt 0 plus. Here this is the ready-made formula of current through capacitor at t equals to 0 plus. So we know IC0 plus equals to 7.5 equals to capacitor of capacitance 5 farad into, we have to calculate this dVc upon dt 0 plus, dVc upon dt 0 plus. So dVc upon dt 0 plus equals to 7.5 divided by 5, that is 1.5 ampere. That is 1.5. This is difference of volt and this is difference of time. So its unit is volt per second. Similarly, we have ready-made formula of voltage across inductor, that is VL0 plus equals to L into dIL upon dt 0 plus. So voltage across inductor, the formula of voltage across inductor is VL equals to L into dIL upon dt. So at t equals to 0 plus, VL0 plus equals to L into dIL upon dt 0 plus. Here also we have VL0 plus, that is VL0 plus is 0 volt equals to inductance of 3 Henry into, we have to calculate dIL upon dt 0 plus. So from here we will get dIL upon dt 0 plus equals to 0. This is change in current, so ampere. This is change in time, so this is second, so 0 ampere per second. So finally we have calculated all of this current across circuit element and voltage across each element, and we have also calculated this dVc upon dt 0 plus and dIL upon dt 0 and dIL upon dt 0 plus. Thank you.